Have you ever wondered what makes something truly powerful? Is it size, strength, or maybe something hidden deep within its very core? Today, we read diving into the story of an element that has shaped our world in ways you might not even imagine. This is the story of uranium and why it might just be the most powerful element on Earth. So, what exactly is uranium? To start, it's a completely natural element, just like gold or silver, that you can find in the Earth's crust. It's listed on the periodic table with the symbol U and the atomic number 92. Now, that number 92 is a big deal. It tells us that a uranium atom has 92 protons in its nucleus, which makes it one of the heaviest naturally occurring elements we know of. Think about that for a second. Out of all the elements forged in the hearts of ancient stars and scattered across the cosmos, uranium is one of the ultimate heavyweights. This heaviness isn't just a number on a chart. It has real-world consequences. One of the most striking properties of uranium is its incredible density. If you could hold a small cube of uranium in your hand, you'd be shocked by its weight. It's about 19 times denser than water. To put that into perspective, imagine a 1-liter bottle of water. Now, imagine that same bottle filled with uranium. It would weigh a staggering 19 kilograms, or about 42 pounds. This immense density is a direct result of its heavy atomic structure and plays a key role in its unique characteristics. It's denser than lead and only slightly less dense than gold and tungsten. This physical property alone makes it a remarkable substance, but its true power lies somewhere much, much deeper. For a long time, humanity had no idea about the hidden potential locked inside this dense, silvery white metal. Long before we knew about atoms or radioactivity, people were using uranium for a completely different and surprisingly artistic purpose. Going back to the 19th century, and possibly even earlier, uranium compounds were prized for their ability to create stunningly vibrant colors. When added to glass, uranium oxide would turn it a brilliant, glowing yellow or green. This Vaseline glass, or uranium glass, became incredibly popular for tableware and decorative items. Potters also used it to create fiery orange and red glazes for their ceramics. It's fascinating to think that for decades, people were admiring these beautiful, colorful objects, completely unaware that they were handling a substance that would one day redefine our understanding of energy and power. They saw beauty on the surface, oblivious to the atomic storm brewing within. This blissful ignorance came to an end in 1896, thanks to a French physicist named Henri Becquerel. His discovery was one of those classic happy accidents in science. Becquerel was studying phosphorescence, the phenomenon where certain materials glow after being exposed to light. He was working with uranium salts, thinking that sunlight was causing them to emit some kind of invisible ray that could fog a photographic plate. One cloudy day in Paris, unable to expose his uranium salts to the sun, he put them away in a drawer, along with a fresh photographic plate wrapped in black paper. To his utter astonishment, when he later developed the plate, he found it was fogged anyway. The uranium salts were emitting their own mysterious rays, completely independent of any external energy source like the sun. He had just discovered radioactivity. This single accidental discovery was a monumental turning point. It opened a door to a whole new realm of physics. Becquerel's work didn't stay a mystery for long. It captured the imagination of a brilliant young scientist named Marie Curie and her husband Pierre. Inspired by Becquerel's findings, the Curies embarked on their own groundbreaking research. They began to systematically test various elements and minerals for these mysterious rays. It was Marie Curie who actually coined the term radioactivity to describe this phenomenon. Their tireless work, often conducted in a drafty makeshift laboratory, led them to discover two new, even more radioactive elements: polonium and radium. But their research also confirmed that uranium was the original source, the element that started it all. They showed that radioactivity wasn't a chemical reaction, but a fundamental property of the atom itself, that the atom was not in fact an indivisible particle, but something that could change and release enormous amounts of energy. And that brings us to the heart of the matter. What makes uranium so incredibly powerful isn't its density or its ability to color glass, but its nuclear properties. Inside that heavy nucleus with 92 protons, there's a delicate balance of forces. For certain isotopes of uranium, particularly uranium-235, this nucleus is unstable and susceptible to something called nuclear fission. Imagine throwing a tiny, fast-moving particle like a neutron at a uranium-235 nucleus. Instead of just bouncing off, the neutron gets absorbed, making the nucleus extremely unstable. Almost instantaneously, the nucleus splits apart into two smaller nuclei, releasing a tremendous amount of energy in the process. But here's the crucial part: it also releases 2 or 3 more neutrons. These new neutrons can then fly off and strike other uranium-235 atoms, causing them to split, releasing more energy and even more neutrons. This creates a self-sustaining chain reaction. It's this chain reaction that unlocks the immense power of uranium. Each single fission event releases a tiny amount of energy, but when you have trillions upon trillions of atoms splitting in a fraction of a second, the total energy released is mind-bogglingly huge. It's millions of times more energy than you could get from burning the same mass of coal or oil. This is the principle behind both nuclear power plants, which control this reaction to generate electricity, and nuclear weapons, which unleash it in a catastrophic, uncontrolled explosion. The discovery of nuclear fission in the late 1930s set humanity on a new path, one fraught with both incredible promise and unprecedented peril. So when we look at uranium, we see an element with a dual identity. It's a substance that decorated dinner tables with beautiful, glowing colors, and at the same time, a substance that holds the key to almost unimaginable power. From its humble beginnings as a pigment to its role in the atomic age, uranium's journey is a testament to scientific discovery and the profound forces hidden within the natural world. Its story is a powerful reminder that sometimes the greatest strength lies not in what we can see, but in the invisible, fundamental building blocks of our universe. It is an element that has fundamentally and permanently shaped human history, and its influence will continue to be felt for generations to come. Thank you so much for joining me on this deep dive into the world of uranium. If you found this journey as fascinating as I did, please hit that like button and subscribe for more stories from the amazing world of science. Let me know in the comments what other powerful elements you'd like to explore next. Until then, stay curious,